Starting off in calculus, what you need to understand is everything in calculus can be split into essentially two different types of processes. Either we are talking about something called a derivative, which may sound vaguely familiar, just maybe from either if you know somebody that took calculus or you've kind of looked through a book a little bit, and then an integral. So all of calculus can be split into that. We call it a derivative or differentiating, and then we call it integral and integrating. So we're going to start. First part of our year is going to be focused on the derivative part. What is a derivative and what do we do with it? So, all of calculus is really about change, how things are changing over time. So, when you look at a curved function, so I have this picture on the left that you're looking at where you have this red curved function. If I were asked to ask you the slope of that curved function, and it might be something more algebraic, you say, well, a curve doesn't have a set slope because it changes over time. It will be different if I asked you the slope up here at the top of the curve than if I asked you the slope at the bottom of the curve because things that are not linear don't have a constant slope. The way that I can work with it in calculus, though, is I can pick 2 points and say, well, I can find the slope between 2 points. I have basic algebra skills. So if you look at the blue line drawn here that connects these 2 points, we call this a secant line. Not to be confused with secant from trigonometry. A secant line is essentially taking any 2 points at a curve, connecting the dots, and coming up with a line that kind of tells you a little bit about the slope between those 2 points. If I wanted to know the slope exactly at a spot, I would have to draw a line that just touches the curve, which is what's happening right here at the bottom. This is referred to as a tangent line, the word tangent meaning just touching it. Um, not the trigonometry tangent. So a tangent line, you might have heard it in a geometry class, is a line that does just touch it at that point. It actually has the exact same slope as the curve. So whatever that line slope is, that's what it's going to be the slope of the curve. Here's the challenge. How do I write a line if I don't know the exact slope? Because I don't have 2 points. I'm just kind of visualizing it. So here's what we do. If we look at this picture on the right and we have a secant line, if I could get those points to be closer together, I would get a better representation of the slope of that graph. Because right now those 2 points are good, but it would be really great if it was these 2 points. Or it'd be really great if it was 2 points that were like so incredibly close to each other. I actually have a way to show you that with technology. I love using Delta Math because I feel like it does so much for me to see some visual things that maybe were harder to see. So here's one on Delta Math. You can ignore the stuff on the right where it had this crazy function and it has this yellow point and this blue point and it draws a line between them and that is your secant line. And you can actually move those points and get those points to be closer together. So notice as I move it, we're changing that line and changing that slope. Ideally, I want those points to be like ridiculously close together because the closer they get, the better that they model the slope at that point. The idea is I want that distance between them to basically be nothing. I want it to go as close to zero as possible. So here's how this works with calculus. Go back to my picture here. So we're going to call this first point x and y, or something you call it x1, y1. And we're going to call this point x with a little distance between it. So this distance that we're between the points, we're going to call that h distance. I have no idea why the letter h is used, but it does get used a lot in calculus. And we're going to say that my y value is f of x plus h. And in fact, I'm going to go over here. Instead of calling this xy, I think it's going to be easier for you to understand. I'm going to call it x f of x. So I have my x value, and then I have whatever I get when I plug that x value into my function. And then if I move a small distance away, we're going to call that small distance h, then my next point is x plus h, and then whatever I get when I plug x plus h into the function. So if I want to find slope, we think about back to algebra. Slope is the change in y over the change in x. I can do a slope formula. So my slope formula is y minus y. So I'm going to use this as my second point, and this is my first point. So I'm going to do f of x plus h minus f of x, so that's doing y minus y, over x plus h minus x. So that is your basic algebra 1 slope formula, y minus y over x minus x. And you're going to notice that your x's are going to cancel with each other. This will give us an equation, a formula for finding slope between these 2 points. Now, we mentioned we need that distance to get really small. That's where limits come in. The idea is we want the limit as this h value, it gets closer and closer to 0. So essentially those points are almost on top of each other. This right here is the formula for how you find the derivative. That right there is referred to as the derivative of f of x, and it is the definition of how we find the slope of a tangent line at any point. So you will see me repeatedly ask you things about what a derivative is. You should be able to very quickly say it's an equation that represents the slope of its tangent line at any point, and what we call it the limit definition or the long definition of a derivative is right here. And please make sure you have that written down. Now, you are going to have some things on Delta Math that are going to ask you to draw some tangent lines. So I actually have that. These are going to be really quick, just kind of giving you an idea of like, what would it look like? What would a tangent line look like? So when you have this picture here, it asks you to move the yellow dot in the upper left-hand corner. That's going to be way at the far left. You're going to put your pencil, your finger, your stylus, whatever on that. And you're going to move it so you can get a really good tangent line at the other yellow point. So when I do that, and I'm just kind of like dragging, you want to get it to model it in a pretty good situation. So you'll see that tangent line. We would say it has a negative slope or a negative slope of the tangent line because it is dropping. And then truly you just hit submit, and there you have it. So that is your slope of your tangent line. The nice thing is they don't ask you to get like super specific with this. So here's one where it wants the slope at 5. So I'm going to move that upper dot over. At 5, it looks like it has a 0 slope. That tangent line is just going to go right across it. And then I'm going to hit submit. And I've got that. So that's just kind of a basic introduction of what a derivative is. We're obviously going to do some practice problems with this, but I want to make sure you're coming in feeling very comfortable about how we even get this formula, this limit as h goes to 0. That's the distance between the 2 points of f of x plus h minus f of x all over h.